Today, we're going to pull back the curtain and unlock the secrets hidden in plain sight. We're talking about the invisible data and the really powerful tools that urban planners use to shape every single park, road, and building in the cities we call home.
You ever been walking through your neighborhood, you see a brand new park or a metro station going up, and you just kind of stop and wonder, why here? Of all the possible places, why did they decide to put it right there? Is it just a shot in the dark?
Well, no way. It's not random at all. It's actually a science, and the answer is all hidden in the data. So come on, let's dive in. We're going to crack open the Urban Planner's Toolkit and see exactly how these massive, city-shaping decisions are really made.
You know, any good toolkit is neatly organized, right? So the first tray we're pulling out is all about understanding the what. This is the foundational stuff, the data about the people and the numbers that really make a city tick. This is what we call non-spatial data. And look, the easiest way to think about it is this. If you can stick it in a spreadsheet or a table, it's probably non-spatial data. It tells us what's happening in the city, but not necessarily where. It's like the statistical soul of the place.
Okay, so when it comes to something as huge as predicting a city's future needs, that's a big deal, right? Well, planners have this one method they swear by. It's considered the absolute gold standard. And this is it, the cohort component method. Sounds a little technical, I know, but what's so cool about it is how detailed it is. Instead of just looking at the total population number, it breaks everyone down into groups, or cohorts, by age and by sex. Then it tracks 3 really key things for each of those little groups: births, deaths, and migration. And this is where it gets really powerful. Foresight. Get this wrong, and your city could end up with tons of overcrowded schools, or the total opposite, a massive shortage of healthcare for an aging population. This method helps them answer that huge question. In 20 years, are we going to need more schools or more hospitals? Okay, so we've got the what down, the people, the numbers, but that's only half the puzzle, right? So let's slide open that second tray in our toolkit. This one is all about mapping the where. And this, my friends, is spatial data. This is the absolute heart and soul of GIS. That's Geographical Information Systems. But really, just think of it this way. It's any piece of data that has a location pinned to it. If you've ever used Google Maps, you're looking at tons of spatial data. Now, this spatial data basically comes in 2 main flavors. First up, you've got vector data. Think of it like connect the dots, but for city planning. It uses points, lines, and shapes called polygons. It's super precise, perfect for things with clean, distinct boundaries. Then you've got raster data. This is more like a photograph. It's a grid of tiny little pixels, and each pixel has its own value. It's amazing for showing things that flow and change across a surface, like temperature or elevation. And check this out. This is how vector data works in the real world. That single lamppost on the corner, boom, that's a point. The road itself, well, that's a line. And that big park across the street, you got it, that's a polygon. See? Simple, clean, and super exact. Raster data, on the other hand, gives us that bigger, more continuous picture. We're talking about stuff like satellite images that show you where the forests are and where the concrete jungles begin, or those cool heat maps showing population density. Even 3D models of the city's terrain that are crucial for things like planning drainage. That's raster data. All right, so we have the what and we have the where. Now for the really fun part, putting it all together. This is where we get to the power tools of planning. And for this section, we're going to call it the planning cake. Okay, just imagine you have a bunch of transparent sheets, like from an old school overhead projector. On one, you've drawn all the flood zones. On another, you've marked all the land that's available. Now, what happens if you stack them? Right, you can instantly see the perfect spot, safe from floods and ready for building. That is exactly what planners do, just digitally. And it's a technique called overlay analysis. You know what? Let's bake one of these planning cakes right now. So you start with your base layer, just a map of the area. Okay, now let's add our first transparent layer. How about the flood zones? See those blue areas? Yeah, we're going to want to avoid those. All right, next layer. Let's add the land use map, showing everywhere that's zoned for new homes. And just like that, by stacking these layers, the perfect, safe, and totally legal spot for a new neighborhood just pops right out. Another must-have power tool is something called buffering. All this really is creating a zone of a specific distance around something on a map. Think of it like drawing a circle, a protective bubble, or an area of influence around a point, a line or a shape.
And I promise you, you see this technique in action all the time. You just might not know the name for it. That rule that says you can't build within, say, 100 meters of a historic monument, that's a buffer. Planners trying to figure out who's going to benefit from a new metro station, they draw a 500-meter walking radius around it. Yep, that's a buffer. Need to see how many pharmacies are close to a new apartment complex? You know the drill. Create a 1 km buffer and just count them up.
Okay, you've seen the tools, you've gotten a look inside the planner's toolkit. How about a little pop quiz to see if you're ready to start building? Let's put that new knowledge to the test.
All right, question 1. A satellite image that's being used to analyze land cover, what kind of data format is that?
It's raster data! You got it. Remember, it's the one made of pixels, just like a digital photograph. Awesome job if you got that right. Okay, let's try another one. The process of creating that 500-meter walking radius around a new metro station. What's that called?
Buffering? Yes, exactly. You're already thinking like a city planner.
So let's do a super quick review of your brand new planner's toolkit. You've got the cohort component method for understanding the what, you've got vector and raster data to map out the where, and you've got awesome power tools like overlay analysis, our planning cake, and buffering to bring it all together and find those killer insights. So the big takeaway here is this. The next time you see a new park, a new road, a new anything in your city, remember, it's not just a random guess. It's the end result of these tools turning mountains of raw data into the smart, real-world decisions that build the world right outside your door. And that leaves us with just one last question for you. You've now seen what's inside the planner's toolkit. So if you had these tools, if you had this power, what's the first big decision you would make for your city? What would you change?